Hello, this is the fifth in a series of videos addressing the installation of Cisco Modeling Labs version 1.2. After deploying the OVA template and performing our preliminary health checks, we will now access the Cisco Modeling Labs management interface. In this module, we will examine the Cisco Modeling Labs UWM interface. This will include views of the interface layout and administrative functions. We will apply the earlier acquired license files to activate the system. And then we will use the UWM to complete the system customizations needed to integrate Cisco Modeling Labs into your testing environment. The User Workspace Management, or UWM interface, is accessed using a standard web browser. The UWM is used to administer various aspects of Cisco Modeling Labs configurations and to control running simulations. It is the interface used for administration of projects or virtual sandboxes and the users accessing them, system administration and licensing, the administration of virtual node images employed within simulations, real-time display of resource utilization and address assignments, and system-level control of running simulations. The default system administrator account is named UWM Admin. This account provides root-level access to the system configuration and resources. This account is not tied to the internal node management network and thus cannot run any simulations. When adding projects and users, the UWM has two assignable roles that affect scope of control and visibility. Upon adding a project, a similarly named user account is created. This user account's role is set to member, which enables this user to run simulations within the project up to any quota limitations administratively configured. Members of a project may access the project dashboard for status information, manage the project environment, and to control running simulations within the project. Virtual node images added by a member are only available to the members of that project. A user account to a project may be assigned the admin role. This extends that user's scope of control and visibility to all other projects running on that server. Virtual node images added by an admin user are available to all users on all projects. The UWM admin pages are accessed via a web browser directed to the IP address assigned to the CML management interface. This will be the static IP address manually configured following the OVA template import. This will return the CML Server splash page. From here, click the User Workspace Management option. Log in with the UWM admin. The main UWM page will default to an overview presentation and display an overall system summary. This will include a listing of the software levels of the CML elements. A system status will show a graphic bar chart of system resources consumed by the CML server. A similar bar chart will illustrate the composite resources used by running simulations. Underneath, a series of bar charts will indicate the resources consumed by each running simulation. Along the left side of the page are the configuration, status, and control options. As the UWM admin account cannot run simulations, the My Simulations and Project Simulation options are not selectable. These are accessible with project user accounts. The Projects option is used to add, modify, and delete the virtual sandboxes within which simulations are launched. A project may have resource quotas set that limit the resources available to simulations. Adding projects will automatically insert a user account with member privileges. A project can be set to a predetermined expiration date or allowed not to expire. The guest project is the other default account. Selecting it, we can examine its standard options. The default settings are enabled with no expiration. In the project quotas section, we see the base resource limits. The user option is used to add, modify, disable, and delete user accounts. The CML server option expands for two sub-level selections. System configuration is used to set the system-level attributes. The system status option allows viewing usage statistics, component health checks, and downloading of various log files. The connectivity option will show a listing of IP address allocations across the 3 external communication interfaces. The VM control option provides system status information and diagnostic features. Many of the diagnostic features can be disruptive and can destabilize the system. The licenses option allows administration of the CML RTU subscription license files for the base server operation plus any node expansion kits. The Node Resources option provides the ability to administer adjunct image files associated with the virtual machines that run within simulations. The Repositories option provides a Git function that enables configuration version management and control that facilitates topology sharing within a team. The Documentation option provides API documentation for the STD and UWM components. We'll return to the UWM pages as we implement various features in simulations. Returning to the Overview page, it is apparent that this new instance of Cisco Modeling Labs has no product enabling license applied. Our next section will cover the necessary steps to apply this licensing. Cisco Modeling Labs uses a static license file keyed to a combination of the CML hostname and the VMAC address associated with the Ethernet 0 interface. License files are distributed through an e-delivery notification process. Product authorization keys, or PAC certificates, are issued via emails which are redeemed at www.cisco.com/go/license. When we completed the OVA template import, one of our verification steps was determining the MAC address associated with the virtual machine's ETH0 interface. Alternatively, we could extract the same information through the UWM's licenses/register licenses option. With the MAC address and the hostname information, we can now redeem the PAC certificate received with our original e-delivery notification. Completing the PAC redemption process will trigger an email containing the license file. Upon receipt of this email, the license file may be applied to the Cisco Modeling Labs server to activate the application. Let's now look at the PAC redemption process. First, we reference the e-delivery notification email. Click the Register Claim Certificates PAC link. This will open a browser session to Cisco's License Administration portal. This will require entering your CCO credentials. After logging on, you will be presented with the Product License Registration page showing a list of PAC token IDs. Select the ID associated with the CML base SKU. Enter the quantity to assign, then click Next. In the subsequent page, enter the CML hostname and the MAC address noted from the earlier steps. In the next step, verify the end user and email information is correct. If the license will be applied by a delegate, add their email to the Send To field. Agree to the end user licensing terms by checking the boxes. When done, click the Submit button. An indication the request is being processed will appear to confirm the redemption. A browser response may be the resultant license file, and a copy is emailed to the designated recipients. With the license file, we can return to the UWM pages. Returning to the UWM page, select the licensing option. Then click the Register Licenses button on the upper right. Refer to the license file received via the PAC redemption process. Open the file using a text editor such as Notepad and highlight the entire contents. Copy the highlighted text to the scratchpad. Then paste into the Licenses field within the UWM page. Click the Register button and confirm the license was accepted and reports the proper node count and expiration date. With the server properly licensed, we can now finish the installation process. This entails customizing the server to meet site-specific deployment details and expected usage requirements. In previous releases of Cisco Modeling Labs, this was done by manually editing configuration files and applying those changes using console-based icon-launched scripts or CLI commands. As before, the icons are one-time use objects on the console desktop that disappear after usage. While these icons and CLI commands are still present and usable, they are expected to be removed in future releases. Cisco Modeling Labs Release 1.2 incorporates the system configuration process into the UWM pages, and this is now the recommended manner to implement system changes. The UWM admin pages now provide an easy-to-use WYSIWYG GUI interface to implement configuration changes. An advantage is that pre-commit summary of changes can be reviewed, and the software components that will be revised are listed. Once committed, these configuration alterations are scheduled as batch jobs with ongoing status reporting of job start, progress, and completion. When all changes are completed, you are prompted to reboot the system. Another significant benefit is the ability to make subsequent changes to the system using the same GUI-based method. Revising Cisco Modeling Labs' default operating parameters is done by selecting the CML Server System Configuration option from the UWM menu selection. The various configuration options are nested within their respective tabs. The System tab is access to set CML Management Interface details and overall host operation. The Networks tab is access to modify the attributes associated with the 3 external communications interfaces. The Viral Services tab shows the default TCP port assignments to the various CML services. The Infrastructure tab shows the passwords associated with the OpenStack and MySQL services and the toggle to enable or disable the guest account. And the Resources tab contains the settings that adjust the compute and memory oversubscription ratios and download proxy options. The graphic shows a quick review of our deployment. Though CML requires the 5 interfaces, we'll only be setting values to 4 of them. Even though we previously set the static IP address for the management interface, we still need to update the UWM interface with the same values. This is to ensure the rehosting script continues to apply the correct settings when the rest of the revisions are applied. In addition to the management interface, the FLAT, FLAT1, and SNAT interfaces are edited with the values appropriate to our integration. As the INT is reserved for future use, we won't have to edit its settings at this time. Returning to our UWM interface, we select the CML server, then the system configuration. We are presented with the System Configuration Controls page showing the System tab. It is recommended to leave the host name as CML. Change the domain name as needed for your organization. The NTP is a required feature as OpenStack needs accurate time information. This should point to an NTP resource within your environment. Enable the RAM disk if you have more than 16 gigs of memory available. Adjust the VNC values as desired. The primary Ethernet port indicates the management interface and should be left as Ethernet 0. The DHCP should be unchecked. This enables the static IP address fields to be manually updated to reflect the address assigned to the Ethernet 0 interface. Edit the DNS entries as to point to reachable enterprise DNS servers or set to a loopback address. Check the box if the system is positioned behind a web traffic proxy and then identify the proxy's URL. Moving to the Networks tab, we can address the 3 interfaces used for external communications. Adjust the settings for the FLAT interface. Edit the scope for the embedded DHCP server offering addresses to internal virtual devices within this network. Then verify the second FLAT interface is enabled. Modify the interface details for the FLAT1 interface as well as the DHCP range for this network. And then modify the same attributes associated with the SNAT interface. Viewing the Vero Services page, we see the various TCP port assignments for the Vero core services. The infrastructure page shows the current passwords and the enabled guest account. And looking at the resources page, we can see the default oversubscription values set for the declared memory and virtual CPU values provisioned to the virtual machine running Cisco Modeling Labs. For simulations less than 50 virtual nodes, the default vCPU value may be left at 3. When the server's total active nodes exceeds 50, it is recommended that a 2-to-1 ratio be set for optimal performance. If a simulation requires a higher ratio than these limits, it is recommended that the ratio be increased in small increments. Running an excessive ratio may make the system non-responsive. If a download proxy will be used, its options are set on this page too. Once the configuration edits are complete, clicking the Apply Changes will return a listing of the modifications showing the current and new values for the affected fields. Scrolling to the bottom, you are offered the opportunity to go back to the configurations or to commit the edits by clicking the Apply Changes button. The changes are acknowledged and the revised configuration files are written. The system reconfiguration is scheduled as batch jobs. Clicking the Refresh button will update the job status. The vInstall rehosting job can take about 20 minutes to complete. When the status is reported as complete, a system reboot is necessary. When the virtual machine completes the boot cycle, log back into the CML Virtual Console. Double-clicking the IP address icon will open a shell tool and respond with the address report of the management interface, followed by a quick check of the other interfaces. At this time, we can check OpenStack's compute services and verify all are enabled and up. We can also check on OpenStack's network services and verify these are also reporting up and alive. Logging back into the UWM, we can take a cursory check of the settings we changed and perform a system health check. And as a recap, in this section, we introduced the User Workspace Management Interface. We did a demonstration that showed the UWM layout and functions. We reviewed the Cisco Modeling Labs licensing process, and then in a demonstration applied a CML license file. We then employed the UWM to customize the system. We completed the configuration to integrate the Cisco Modeling Labs into an existing lab environment. That was followed with a demonstration showing the same technique.